Hello and welcome to this video. In this video I want to talk about the recent CVEs that were dropped on the CAPS project by an Italian security researcher called evilsocket, and in name he is called Simone Margaritelli. Now, why do I want to talk about these CVEs? Well, first of all, because technically they are interesting, they deserve some interest with respect to the technical part. I would say that in this video, we will read the blog post, the first write-up by Simone directly in his blog, evilsocket.net, Attacking Unix System via CAPS Part 1. So we will delve into the technical details by reading the blog, and I think it's interesting the way he found the vulnerabilities. And then what's even more interesting is the way that the responsible disclosure process happened. This is because, as we will read in a blog post, Simone found the vulnerabilities in a weekend of hacking, essentially, and then he tried to report them to the developers, who essentially, from what it seems, from the things we know at this point, it seems that they can ignore the vulnerabilities, or anyways they downplay them. This created a lot of confusion, also because there was a CVSS score of 9.9, which was actually way too high with respect to the vulnerability. I mean, the vulnerability is more around, like, I would say an 8. So a lot of hype was created about this. And I just want to read the blog and comment it with you. So I hope the video is enjoyable. If you find it so, subscribe to the channel, help me grow, support me, and that's it. Enjoy the video. So essentially, Simone starts the blog post with a quote from, I would say, a developer, or anyway, someone who is directly involved in the CAPS project, who said, "From a generic security point of view, a whole Linux system as it is nowadays is just an endless and hopeless mess of security holes awaiting to be exploited." Now, this quote, I would say, is way too generalistic. That's not how you secure a system. You secure a system by understanding exactly where are the security holes. These kind of phrases, often we say very general phrases, but essentially they mean nothing. So I guess, from what I understand, Simone got this reply while he was trying to report the vulnerability. So it's kinda sad, to be honest, because once we have a real vulnerability, we should assess the risk of the vulnerability. We should try to understand how to deal with it and what is the actual impact. We should not just reject it altogether, saying, oh, there are so many issues anyways, what's the problem here? So what's the summary here? The summary is that there have been released 4 different CVEs on the CAPS project in the different sub-projects, like CAPS Browsed, libcaps filters, libppd, CAPS filters, and the last one of these, the CVE 2024-47177, allows the execution of arbitrary commands with a user interaction. This is going to be important to understand the impact and the severity of the vulnerability, but essentially all these 3 other CVEs bring the 4th one, so like they are chained together to actually obtain remote code execution. And then he says that there are other bugs that have not yet been assigned CVEs, so probably what I expect to happen is that in the following days, like, more security researchers will look at the source code of the CAPS project in general, and maybe they will find something else, maybe not, we will see. So what's the impact? Is that a remote, unauthenticated attacker can silently replace existing printers or install new ones, EPP URLs with a malicious one, resulting in arbitrary command execution on the computer when a print job is started from that computer. So essentially what it's saying here is that, let's say that I have 2 computers in the network. So I have PC1, and PC2. Let's say for now that they are connected in the same LAN, so there is a connection between these computers. We don't know how exactly that connection is performed. In particular, PC1 is our victim, while PC2 is our attacker. And PC1 exposes the UDP port 631. So with this configuration, a malicious attacker can send a specific packet to this port listening on UDP 631, and by sending this packet, he can essentially register a printer, which is of course controlled by the attacker, and then when the user goes for printing stuff and uses the malicious printer, a command execution is triggered on the PC1, so on the victim machine. So it requires user interaction. This is an important thing to understand, and we have a remote code execution under a user interaction. So, what are the entry points? Either you expose a CAPS browse did service on the UDP 631 port, or you are in the same local area network, because it's saying that, and this is going to be explored more in the second part if it comes, essentially that you can spoof advertisements that allow you to inject the malicious printer inside the victim machine. So I suppose it's because probably the victim machine is gonna ask the local network what are the printers here, and you as a malicious attacker can say, look, I'm a printer here, even though of course you are a malicious printer. So I suppose that's the idea. So it's either in the local area network or in the public internet if you expose this specific port. And this also brings us one of the remediation. The simplest one is disable the CAPS browse this service, so disable this specific service, which is the entry point that allows the attacker to inject the malicious printer inside the victim machine, and have a firewall on that blocks all the traffic going to this port. There is no authentication, no check is made, so like if you have this open port and if you have the service running, you might be vulnerable to this attack. So quoting one of the first comments from the guy who literally wrote the book about CAPS while trying to explain me why this is not that bad, I'm just pointing out that the public internet attack is limited to servers that are directly connected to the internet. Now this is what I would define as a tautology using the language of logic, tautology. It means essentially it's saying that the existence of A implies A. I mean, this phrase just repeats 2 times the same thing. Saying that there is a public internet attack means that every server that publicly exposes that port is under threat. So in this case, for example, if you are in a public internet, for example, a VPS, I check my VPS and do not use this service, but let's say they did, then everyone in the internet could attack me by just knowing my IP address and just sending the malicious package. So like, that's the idea. So affected system, a lot of system run CAPS, and CAPS is used to like print stuff essentially. And I think it's used also in macOS. And since during the exploitation you register a printer and then the machine pings you back with information on the actual machine, like the kernel version, like the output of the uname command or something like that, and other stuff. So like the researcher Simone essentially tried to understand how many servers were vulnerable, so he just sent these commands to the various to the command to register a new printer to the various servers that publicly exposed the 631 port, and he got a lot of connection, and here he made up a file with all the different systems that ping back his machine essentially. We can see we go from Linux 2.6 to, I would say, even the most recent version 6 point stuff. So it's like a lot of version run this thing. Of course, it depends also on your distribution. Some distribution do not activate this service by default, some others do. So then it depends on the specific configuration and distribution of your machine, but it's easy to check. Just do a netstat and you should find if the port is open or not. Oh, and just so that we're clear, the command you can use is this, netstat udp listen, and it's gonna print out all the listening port on UDP, and you check if you have a 631 number there. It means that the CAPS service is running with that particular port, and you should do something about it. So remediation, disable and remove the CAPS browsed service if you don't need it, which you probably don't, because I believe this CAPS browsed is used to browse the local printers. So even if you want to print, maybe you don't need this service, you can just specify your printer in a configuration without having a service finding for you. Update the CAPS packages, and if your system cannot be updated, of course you have to block all traffic. And then it says entirely personal recommendation, just remove the library from any system. I mean, this is personal, as he said, so take it as you will. If you don't need to print, why have it installed, I would say. And if you do need to print, then make sure that that specific computer is firewalled from incoming connection. So like the listening ports only accept traffic from specific whitelisted IPs and not from everyone in the system essentially. So intro, and then he explains how he understood this vulnerability, which is a very fun story because essentially he got a new computer and then he was like, okay, let's see the UDP listening ports. I mean, let's see the ports. And essentially found this UDP 631. And he was like, okay, what is this port about? And then he understood, okay, it is about CAPS. And he was like, okay, what is caps browsed, he googled and he found the source code of the service. And the first thing that he noticed is that in the source code of the service, when the service binds to the network interface, it actually uses here the value in a DDR any, which means bound to all network interfaces. Now this is already like problematic essentially, because sometimes you don't want to bound on a public exposing network interface. Like for example, if you have a publicly exposed server, you just want to bind to the internal intranet networks. So like, of course, this only affects, I would say, a machine that is exposed to the public internet. Because if you are under a LAN, if you are in a LAN under a NAT, even if you do any addresses, essentially, it's sort of like you are protected from the public internet through the NAT in the router. However, if you have one of your interface which is publicly exposed on the internet, on the entire public internet, then this thing is not really that good. So even in this, I would say it's like, it's just not that good to have it like this. So reading further in the code, he analyzed that the function process browse data is reading a packet from the socket essentially. So receive from browser socket. He does some error checking. He checks if this packet is allowed. If it's not allowed, it's sort of, there's like a sort of like authentication check, we could say, and then it keeps on going. Essentially, this service expects a UDP packet with the format xnumber text data, and if the allowed function returns true for the specific source IP, more things happen later. So it seems like you have this kind of authentication mechanism. Now at this point, one has to ask, okay, what is the allowed function? What does it do? What does it check? And of course, this meme tells us that this check is kinda funny. And essentially, the idea is that with the default configuration, anyone can connect. It probably means that this software uses a blacklisting approach. So like to specify maybe if the configuration file is empty, anyone can connect, which instead they should probably like by default, no one can connect, and then I whitelist specific IPs. So I would say this is not really a secure by default design pattern in terms of security. I think it can be improved. I'd rather have a configuration that allows me to specify which address I want to allow to connect essentially. So later there's some, he mentioned this stack buffer overflow and race condition. So the way in which this packet was parsed, he analyzed it with a fuzzer and he found some crashes, and then he gives the outputs of those crashes. I've also analyzed other researcher on X/Twitter saying that this buffer overflow is a stack overflow of 1 byte, and as of right now, there seems not to be a way to exploit it. So this specific vulnerability probably not that useful, but still a vulnerability. I mean, here the difference is a vulnerability still has to be addressed somehow. If it's exploitable, of course, the impact is much greater, but nonetheless, the vulnerability is still there and it has to be addressed. So both of these issues have been reported and thoroughly documented to the devs and the cert, but nobody seems to give a damn. I can tell you that there are other most easily exploitable paths going on, so like this code base could be interesting target. So at this point, essentially, there's no authentication, so anyone can connect and use this service. So at this point, essentially, we have that we can send a UDP packet to the victim machine running this service, and then what happens? So by looking at the structure of the packet, essentially, it says that, okay, look, there is a URL, it's URI, the remote host URI location info. After some further validation and parsing, this URL and other data are then passed as arguments to the examine discovered printed record function, which ultimately execute create remote printer entry. And the create remote printer entry will call the cf get printer attributes from the libcaps filters. And so essentially here the idea is that he can send a specific UID packet containing an attacker control URL, and when the caps browsed service will read that packet, it will actually query that URL to connect it. It's sort of like it expects a printer and it's going to join the printer in the machine listing, and so it's going to connect to the printer. And here it shows that he got these hitbacks from the various services running. So the idea is that you just send a UDP packet and you get a callback. So Internet Printing Protocol, the Internet Printing Protocol IPP is a specialized communication protocol for communication between client services and printers. It allows clients to submit one or more print jobs to the network attached printer. So essentially now the system believes that the malicious actor is now a printer, or he can control where the printer is anyways. And so at this point, he can configure the printing job. So the idea essentially is that the next time the user is gonna print, he's actually gonna use a malicious printer, and in that moment, when that thing happens, when that user interaction happens, a series of things will happen, and the printing job sent by attacker will be malicious, and it will trigger the remote code execution. So I went back to writing some code, and by using the EPP server Python package, I was now able to respond properly with attributes I controlled to the service request. My fake printer was immediately added to the local printers with no notification whatsoever to the user. So essentially, the first step in is adding a malicious printer. It looks like the service fetches these attributes, so the attributes sent by the malicious attacker, and then creates some sort of temporary file, a PPD, on which these attributes are possibly saved. So then he searched more for the code, and then he realized this particular section of the code where there's a lot of writing into this particular file, which is the PPD, PostScript printer description. And essentially here, I believe there's some input control data, and you're able to inject arbitrary content into the specific file. And look at this, here there is no like validation. So in this case, essentially what happens is that these are user control data, I believe. I mean, from what I understood, this is user control data. And here it just prints into this file with no validation whatsoever, because this single slash quotes can easily be bypassed by an attacker. So this is where input validation should come in, which in this case it isn't. And I think this is another CVE probably. Notice how many attributes are printed and escaped into the file. The print, make, and model is just one of them. So the PPD files are created by vendors to describe the entire set of features and capabilities available for their PostScript printers. A PPD also contains the PostScript code commands used to invoke features for the print job. So essentially, when a print job is executed, the printer can send these specific commands. So a PPD file is a text file provided by a vendor that describes in a domain-specific language the printer capabilities to CAPS and instructs it on how to use it properly. It looks something like this, and there are a ton of different instructions and filters, and specifically, he found this CAPS filter 2, and with this CAPS filter 2, you can execute commands. So this string keyword provides a conversion rule from a given source type to the printer native format using the filter program. So it is used to convert program in different formats, but of course for a malicious attacker, the idea is that, wait, with this we can execute a program. Now the problem is that the filter is any executable, so any program, but contained within the specific path, which is user-lib caps filter, which is of course not writable by the remote attacker, because now the attacker has no access to the file system of the victim, so it just has to use the binaries that are already there in this specific path. And so the question now was, okay, what kind of filter can I use to obtain common execution, remote code execution? And the filter uses this foomatic-rip. So this executable has a long history of being leveraged for exploitation, starting from the first node CV 2011, so like June 2011. The idea is that the filter accepted the foomatic-rip command line directive in the PPD, which allow any command to be executed through it. So essentially, this was fixed after it was reported in the CVEs. However, when this thing was integrated in the CAPS system, the fix was not ported to CAPS. So essentially, I believe it was another printing system that had this foomatic-rip filter, and then they ported it to CAPS, which without the fix. And so, of course, this is another problem that then led to the command execution. Foomatic-rip was a known issue. Why is something that allows arbitrary commands in a generally untrusted context not considered a security issue worth fixing? Because it's very hard to fix. So they say, like, this is from the CAPS developer, it is very difficult to limit what can be provided in the foomatic-rip command line in the PPD file. So when we are talking about fixing stuff, we're talking about validation. Now, to do validation, you need to understand exactly what is the input you expect and what is the malicious input in a way. So the best way to validate is through whitelisting validation, which just focuses on what is the expected input you should have. And if you find something else, something that is not conform to the expected input, then you discard that, you do not process that. However, the problem is that since this is used in legacy system with old printers, and since these old printers do some crazy shit like this kind of like, what is this? It's like print, it's like GS, Perl, like they use a lot of different commands in a very weird and unconventional way, which shouldn't happen and which represents a high security risk. Essentially, they cannot really validate that much. So I had no idea that this can happen every time you print something, and to be frank, it's quite scary. They have to allow foomatic-rip command line to accept pretty much anything, including Perl, as you can see, or many printers will just stop working on Unix-based system. So what is the chain for the remote command execution? So the idea is that force the target machine to connect back to our malicious EPP server, and this is obtained by the UDP non-authenticated port essentially. Then the attacker can return an IPP attribute string that will inject controlled PPD directives to the temporary file, so in the first connection, and then when a print job is executed, the CAP service will be like, okay, wait a second, the malicious printer was configured to require this sort of command to be executed for the printing, to be conform with the printing process, and that's exactly how you get the command execution. At that point, the CAP system will execute the malicious command inserted by the remote attacker. So that's essentially the idea. And then in this video it shows the thing, and then there's a lot of consideration with respect to the disclosure process, because what happened essentially is that he found these things, took 2 days of research, 250 lines of Python for the working exploit, and then he tried to disclose it to the developers, and apparently it was not easy to let them agree that this was a security issue. Now there was also a CVSS that was given by 9.9, 9.9 severity, which is not really correct, because for example in this CVSS, I mean later I can do a full video on this, but essentially the CVSS score should be a way to quantify what is the security risk of a given vulnerability, so that business and companies can understand with vulnerability management if it's worth to fix, how much effort should be put, what kind of vulnerability it is technically, so what kind of targets, what is the assumption, the requirements, and the general structure of the vulnerability. Like in this case, for example, we have this UI:n, which means user interaction none. N means none. Now, user interaction none means essentially that the user, the victim, doesn't have to do anything to be attacked. But in this case, clearly this is not true. Why? Because the user has to click on the print job to be attacked. So this CVSS, which was not computed by Simone, but I believe by some Red Hat engineer, essentially was not computed well. There was some probably miscommunication. The vulnerability was not well understood, and this allowed for this CVSS to be very, very high. I'm not sure if they recounted it. So apparently I went to check the Red Hat customer portal for the CVE that we analyzed, that we read, and before it was 9.9, but now it's actually downgraded to a 6.1. I would say maybe a 6.1 is a bit lower. I would give it something between a 7 and an 8. So if we check the actual CVSS score, the CVSS score breakdown, now we have attack vector local, which I would say it depends, because if the server is exposed to the internet, the attack vector is actually the network, so it's like the public internet. Then we have attack complexity low, which I agree, privileges require low, which I agree, user interaction require, which I agree, and then you have the impact on the confidentiality, integrity, and availability. Well, to be honest, if you actually manage to reach RCE, these are actually all high, because you have remote command execution on the system. So I'm not sure why they put confidentiality and availability in low. So now the score is kind of a little bit too low for my taste, and it was updated recently, so today essentially. So this also goes to show that sometimes if the CSS score is not correctly computed or is too far from the actual vulnerability, it can create a lot of confusion. And of course, to understand the correct score, one has to understand the vulnerability and how it works exactly, and what is the impact of the vulnerability. But essentially, it's very interesting. It is a very interesting attack surface area, services which we normally don't even know that are running in the background, things which we normally don't know how they happen. Like for example, this is one of the most scary parts because everything else before that can sort of be remediated. You can maybe put UDP only on specific internal network addresses. You can use whitelisting to authenticate IP addresses within the LAN and things of the sort. For this thing, there's actually no way to validate this because if you want to support old printers or printers in general, and these printers are configured with these crazy commands, you are inevitably opening up your computer for security risk, because this means that the code by design, this is like sort of like a design and legacy issue, by design is vulnerable, and on an implementation level you cannot do much to avoid this. Maybe the only thing you can do is execute those commands in a sort of like virtualized environment or a container environment, so that you have some sort of like isolation with respect to the environment where these commands are executed and the actual environment of the victim machine. But other than that, there's not much you can do. So essentially, very interesting blog post. I suggest you to go and read it fully. And also another thing is that he did a responsible disclosure, and then his exploit with the initial report was actually leaked. So this is also like a bad thing, I would say, that happened with respect to the process of responsible disclosure. So when I initially wrote exploit, it only said UDP packet. Of course, Simone has contributed to a lot of open source projects, among which BetterCap is one of the most famous. And he said that essentially he integrated a module for attacking the service advertisement by ZeroConf, Monsure, and Avai on a LAN, and integrated this in BetterCap. So if you don't know about that, just check out his projects. All very, very interesting. So this is it for this video. I think that it's really cool. I really like the style of the write-up because it kinda goes through his mind, like what he was thinking and essentially the various steps. And it's very easy to follow exactly because of this reason. It doesn't start from the end. It starts from the start. It's like, look, I buy a new laptop and I find a UDP port listening. What do I do? Well, I would say he's experienced enough to understand that you can actually check the source code for open source projects. You can actually try to understand what they do and if they are vulnerable. Of course, this is why I think this write-up is really cool, because it just goes to show how much you can discover if you put some curiosity and if you put some time into the stuff you do and into the technology you use. As a final note, I would say that both researcher and developer, they have to come together to actually handle security. Researchers have to be clear and they have to be communicative, which from what I understand, I believe that Simone tried to be communicative at the start with all the details, but the developers have also to understand. I mean, if they ship a product, it is ultimately their responsibility to make sure that that product is secure and that it follows specific security guidelines. And this is for the security of everyone, because most of us use software, and most of us use software that we don't even know, that we didn't even choose to install in our machine. So to increase the security of everyone, we have to really be careful when, as developer, we write new software. There is this responsibility, which I believe should be honored in a way. So this is a sad story because from what I understand, Simone had to also a little bit create the hype at the end to force the developer to start push the fixes. Because initially, when he was just detailing, when he was just doing the disclosure privately, discussing the issue, from what I understand, I might be wrong, but from what I understand right now, the developers just did not want to listen. And I believe this is not a good approach to handle security. If anything, we just have to teach people the fact that not all security vulnerabilities need to be fixed in terms of code, but all security vulnerabilities need to be addressed. Like, okay, I accept the risk, or I try to change something in the environment or in the default configuration to make sure that the risk is less, that maybe I do not accept any arbitrary printer, but I only accept printer from a whitelist of IPs, and so on and so forth. I mean, there are many ways to handle these things. Even though sometimes we cannot have the technical correct fix, we can still do remediation around that. We just have to be, I would say, curious enough to understand and to want to improve the software we create and we use every day. So this is it for this video. I hope it was fun, I hope it was enjoyable, I hope you got something out of it. Go and read the write-up by Simone, go and follow his other projects, and that's it. Support me, subscribe to the channel, and see you to the next video.